Well, thank you very much. Thank you for the intro. So today, in these 10 minutes, I'm going to try to cover how to run basic inference and edge devices. I'm going to do everything from my laptop, but I'm going to try to recreate an actual real-world scenario with Kepler and Kubernetes. So this matters because I feel, in my experience, all of the AI is getting anywhere. It's getting everywhere. It's not only huge corporations and huge data centers. Everybody is trying to run small models, and the edge is not an exception, right? So everything is moving anywhere. The obviously small inference models, right? So the tech stack that we're going to use today is going to be K3s, a very lightweight Kubernetes distribution, Kepler to export the metrics of the model, and then Prometheus. Everybody knows Prometheus, I think, in this room, and then a very small model with ONNX Runtime. Okay. So this is the basic workload that you can see this YAML file here. It's a lightweight container that's basically control. Because we only have 10 minutes. I've recreated this, and I'm going to show the graphic in the next slide. But I think, yeah. Can you? Good, great. So I have Prometheus and Kepler running in my Kubernetes cluster in my laptop. Everything is running locally, so you don't need to spend a lot of money. But the key point here, I think, is to be able to see that. Sorry. That everything is kind of imitating Kubernetes distribution on the edge, which is very small configuration for like a small edge device, right? So you can see the graphic here. This is what I emulated. So you can see that there is like a needle baseline of 2.3 joules, which is slow, like small consumption of energy. But then when I run the inference, that you can tell here, it spikes the energy. This is something that obviously when you're running on the edge, you care about what are the limitations of my hardware, but you don't check often the energy that you use when something's happening at the edge, right? So that's what I wanted to show you guys, the energy monitoring with Kepler. You can export with the exporter, you can see what's happening at the edge and make decisions based on that. Is a concern of energy a thing that's gonna worry you? I think nowadays it is, and especially with all of these energy after AI workloads. So you can see here, like, as I said, the idle baseline is 2.2 joules, and then, when this spike happens, what we learned today is, the measurable impact that we are able to do with Kepler and ONNX. So a small, visibility of what we can do and achieve, and especially if you want to check what's happening behind your devices. So this will bring, obviously, a lot of optimization opportunities after you have the data, because let's not forget, decisions in these type of environments are based on data, and data is key. So that's why, having a measure what's happening in your edge devices is critical. And then the architecture dive would be something like an edge device with, a sensor or a camera. Then Kubernetes cluster with K3s to orchestrate containers at smaller runtime with ONNX, and then Kepler to measure energy, and Prometheus to scrap and see the actual graphics. A real-world impact around, as you saw in the graphic, is like more than 5 times the amount of energy consumed in that specific inference. And then you don't need any additional hardware to make this happen, because everything is software. And the potential savings, especially if you are going to act on the graphics that you just saw, you're going to be able to save a lot of money, especially in huge corporations that manage thousands of devices. Let's talk about solar panels. Let's talk about all of these tiny devices that are happening on the edge. And then it was nice to see you. I only had 10 minutes, so I covered this in like 4 minutes. So thank you very much. If you want to provide any feedback, it was nice to see you, and you're welcome to give me feedback. Thank you very much.